Hello students, so welcome to our video 2 in which I will teach you geometric progression. I hope students you have watched my AP video class, and this is the next part of it, or the next part of this chapter, and we are right now in geometric progression. So I will teach you geometric progression right now, which is abbreviated as GP. GP stand for geometric progression. So student, in arithmetic progression we have seen what is the first term, what is the common difference, what is a nth term, and what is Sn, that is the sum of all n terms. So similarly over here we're going to see that same terms. So let's understand student first of all what exactly is the geometric progression. So student, what exactly is geometric progression? I'll start teaching right now. Say, suppose we have numbers like 1. Say we have number like 1. Now if I do double of it, let's say that becomes 2. Now if I do double of 2, that is 4. Now if I do double of 4, it is 8. Now if I do double of that, that becomes 16. Now if I do double of that, that becomes 32. So actually this is geometric progression. So what exactly is the geometric progression? Say when the sequence have common ratio, when the sequence have same common ratio. Now what is common ratio, student? Please understand. Like in arithmetic progression we have common difference. Now we will have common ratio. So what is common ratio, student? Common ratio is nothing but succeeding term divided by preceding term, or second term divided by first term, or else third term divided by second term, or else fourth term divided by third term. So student, I hope you have understood 4 by 2, which is 2, or else 2 by 1, which is 2. Hold on.
आपका फिर जाएगा
So, sorry students, there was some technical issue which I have resolved. I guess now henceforth we will not have that kind of term. So anyway, so what is common ratio? I hope you have understood, student, by now. So the common ratio is second term divided by the first term, third term divided by second term, fourth term divided by third term. That is nothing but succeeding term divided by preceding term. So succeeding term divided by preceding term. So let's say 2 by 1. Succeeding is 2 and preceding term, which is 1. So succeeding term divided by preceding term. That is common ratio. Now which is generally denoted as R. Like how we had in APD, in geometric progression we will have R. So R stand for common ratio. R stand for common ratio. And again we will have the same thing as like 1, which is nothing but A. A stand for, yes, those who were like attending last class, they know A stand for arithmetic progression, A stand for first term. Similarly, in geometric progression, A stand for first term. R stand for common ratio, A stand for first term, A stand for first term, and R stand for common ratio. I hope student you are understanding everything. In case not, don't worry, you can put it in your comments and I'll quickly reply on that. So student, we will continue right now. Um, so in case if you have to calculate AN, and now what is AN? By now we understood A stand for first term, R stand for common ratio, and AN. AN is nothing but nth term of the geometric progression. Nth term of that geometric progression. So nth term का formula again, like do you remember in AP what was AN? It was A plus n minus 1 in bracket into D. Like that way AN in geometric progression will going to be A r raised to the power n minus 1. Again AN is equals to A r raised to the power n minus 1. Again AN is equals to, that is nth term of geometric progression is equals to first term into the common ratio raised to the power n minus 1. So student, please note that the n minus 1 is only for the power. I mean this power is only for r, not for a. So generally error happen. People take AR in bracket and raised to the power n minus 1. It is not. It is only r raised to the power n minus 1. I hope you have understood. Please note down student this formula. This is AN formula. AN is equals to A r raised to power n minus 1. I have noticed that many students do not put that notebook and pen aside. So I'll wait for a moment because everyone please note down. These all are important notes. Okay, I hope you finished writing this AN is equals to A r raised to power n minus 1. And now, say suppose, again the same thing like say we have over here stop, isn't it? That means if there is a dot, then this is called as finite geometric progression. And if there is dot, then it is infinite geometric progression. So first of all, understand what is the basic difference in arithmetic progression and the geometric progression. So in arithmetic progression, we have common difference. In arithmetic progression, we have common difference, and in geometric progression, we have common ratio. This is like a basic difference between these two progressions, or basic difference between the two sequences. So AN is equals to A r raised to power n minus 1. So suppose this is like the given sequence 1, 2, 4, 8, 16, 32. And in case if we have to find, say, what would be the 10th term of the series. So, or 10th term of the sequence, or the 10th term of the progressions. This all means the same, just in a different language. So suppose if I am trying to find what is 8, 10. So how will I find this 8, 10? 8, 10 is nothing but the 10th term of that geometric progression. 8, 10 is nothing but 10th term, like 1, 2, 3, 4, 5, 6, and like that. What would be the 10th term? I hope you are getting this. 8, 10 is nothing but 10th term. So what is student at? So A is 1. Look at it, I have written already. A is 1. R is, we've already written, this is R. A is equals to 1. R is equals to 2. So 1 into 2 raised to the power n. N is over here 10. 10 minus 1, which is 2 raised to the power 1 into 2 raised to 10 minus 1, which is 9. So one can leave over here the answer. And some people are so anxious to know what is this 2 raised to the power 9. Actually, 2 raised to the power 9 is nothing but this. This is like 2 into 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 2 and into 2. How many times? 1, 2, 3, 4, 5, 6, 7, 8, 9. That is that many times. So one can do that orally. Like 2 is a 4, 4 is a 8, 8 is a 16, is a 32, 64, 128, 256, and 512. So what is that? 512. But this was very simple at this case because the number base number was 2. It is not necessary in all the sums you'll be able to do this. So in this case I could do, but not necessarily in every case you have to do that. So one can stop over here as the answer. I hope you are following. And now the next thing comes in the picture. Some specific terms like what is SN? What is SN in this case? Yes, student. And one more thing I forgot to tell you, like that. Say over here, this R can be a negative number, or this R can be positive number, or R can be fractions. Just remember that R cannot be 0. It can be 1, it can be positive, it can be negative. So R, depending on that R, we have 3 formulas of Sn. Now what is this Sn, students understand? Sn is nothing but sum of all first n terms. Sn is nothing but sum of all n terms. So the formula is A R raised to the power n minus 1 upon R minus 1 in case R is more than 1. But if R is less than 1, if R is less than 1, A 1 minus R raised to power n upon 1 minus R. If R is less than 1, and if R is equals to 1, then it is simply NA. If R is equals to 1, then it is simply NA. So let's student revise once again. What is this S stand for? Sum of first n terms of GB. So if this R is more than 1, the formula is A R raised to power n minus 1 upon R minus 1. So student understand, when R is more than 1, R come first. Then when R is less than 1, then 1 comes first and A into the bracket 1 minus R raised to power n upon 1 minus R. If students this R is equals to 1, see, understand, I'll give the example, then you'll understand what I'm saying. Say, suppose the R is 1. Suppose the R is 1. Say, my first number is 5. My first number is, let's say, 5. And now we are forming a geometric progression where first term is 5. And our R is 1. A is 5 and R is 1. So student, what will be the next term? What will be A2? 5 into 1, that's 5. What will be third term? 5, the preceding term into R, that is 5 into 5. I hope student you are understanding this. So I was just checking the comments. So someone had asked, sir, can you give the example of when the R is negative? I will surely give. just hold on, I'll give the example for when r is equals to 1. So when r is equals to 1, the progression remain the same number. So in case if you have to find say sum of first 5 terms, Sn. So sum of first say 5 terms. So 1, 2, 3, 4, 5, like kgs. So how are you going to do that? 5 times first number. That's easy, isn't it? I hope you have understood this. So when r is negative, what will be r is negative? Say 8, 4, 2, 1. Now, if you do that, negative I means it would be inverse. Inverse means like say earlier ratio was 2 and now it will be 1 by 2. Say succeeding term divided by the preceding term. So it will be 4 divided by 8. So that will become 1 by 2, isn't it? Or 2 divided by 4, which is again 1 by 2. So say I read it, it is not negative, it is less than 1, and this is more than 1. When the ratio is more than 1 and when the ratio is less than 1. Sorry, the word negative was wrong, it was inverse. I hope student you are getting this. So when the ratio is half, what is the formula? Say suppose the first term is 8, 8 into half, 4, 4 into half, 2, 2 into half, 1, 1 into half, 1 by 2, 1 by 2, into half, 1 by 4. This is how we form the GP. I hope students you are understanding or liking it. Yes, so shall we start solving some sums? Okay, students, before proceeding to the sum, we'll have to understand a few concepts. Like, say, suppose in case if we were to choose certain terms, like like 3 terms in case if we were to choose, or 4 terms we were to choose, or 5 terms we were to choose, then how our choice should be of the numbers. So, what by now we have learned, student, please understand. Let's revise first of all. We've learned what is A. Then number 2, A is nothing but the first term. Number 2, what is R? R is nothing but common ratio. 3, we've learned AN. What is AN is nothing but the nth term of the geometric progression. Then 4, SN. SN, like SN is nothing but sum of all the terms of that particular geometric progression. SN, we've learned 3 formulas, 1, 2 and 3. When r is more than 1, when r is less than 1, when r is equals to 1. This is what we have by now finished. So let's move further on the next formulas. Say suppose we know if there are 3 numbers which are in GP. So 3 numbers are in GP, like let's say the first number is A, second number is B and third number is C. So, student, understand what will be the common ratio in these 2 terms? B by A. And what will be the common ratio in these 2 terms? Succeeding term divided by the preceding term. So, C by B. And supposed to be, this is supposed to be equal, isn't it? Because the common ratio is the same. So, if the R is same, these 2 numbers will going to be same. So, what it becomes? B square is equals to AC. That implies B square is equals to B square is equals to AC. I hope students you are understanding what I mean. B square is equal to AC. Do you remember in the ratio proportion I have already taught you what is continued proportion. So it is a part of the continued proportion. So why is B square is equals to AC? Middle term square is equals to product of the extreme. So it is continued proportion. And why is that? Because the ratio is the same in this case. So somewhere the geometric progression is related to your continued proportions also. I hope students you are following till we've learned a few concepts of geometric progression. Let's move to the next concept. Say suppose we have to in some questions we have to choose like say three terms of the geometric progression. So one can take A, B, C also, or some people may take something like this also. Say number of terms and actually terms. So in case if we are choosing say three terms, then your choice should be say middle term would become A, middle term should be A, and thereafter term would be AR, and these terms should be A by R. I hope student you are understanding. So in case if you were to choose your three terms, then choose like this way. A by R, second term should be A, and third term should be AR. Please understand this is AR. So why this is how we are choosing the terms and how exactly so you have got all that things questions definitely right. But anyway, when I will solve some sums based on this, then you'll understand student, I hope. So in case if you were to choose five terms, see students understand the middle term will remain same, A, and then the thereafter term will become AR and preceding term will become A by R. So this is how we're going to choose middle three terms, and then the five terms will be like this way, AR square, and this will become A by R square. Is it a geometric progression, student? Yes, it is a geometric progression. So this is how we choose our five terms. In case if you were to choose any four terms, say understand student, in case if you were to choose any four terms, then our choices would be little different. Please understand. Then our middle two terms would be A by R square and AR something square. If you were to choose AR and A by R, so the middle two terms are like this, AR and A by R. I'm choosing four terms. So the next term will become ARQ and A by RQ. I hope student you are understanding. Even this is a geometric progression. And over here the first term will be A by RQ and the common ratio would be 1 by R square. So if you multiply if you multiply everything by R square, you're going to get this series. Say if you multiply these by R square, I'll give the explanation. A by R cube into R square. It will become the next A by R. If you multiply these R cube and R square will get cancelled, so it will become A by R, which is over here. And if you again multiply by R square, you're going to end up with this. And again, if you multiply this AR by R square, we're going to get this. So AR cube. That is how we got our first four terms as like this. So anyway, student, most of you might have difficulties. I could see in the comment box. Yes, someone had asked me this as a doubt, sir, why are you explaining this? So student understand these are some few concepts of geometric progressions, and when I am doing the geometric progression, I should do, right from the basic onwards. Say, I'll give one example based on this. Say sum number 27. Find the three numbers in GB whose product is 216 and sum of their product in pair is 156. Okay.